Hey guys, welcome back to another KevCAM night school tonight. Tonight I have something a little bit more special than the usual here. Have Justin Fuqua helping out with some pretty complex 5-axis impeller. Going to show us some pretty nice strategies and kind of as a 5-axis wrap-up also. So definitely feel free to ask those questions, and we'll also have Tim Micah helping out tonight with the questions and stuff that comes up along the way. So, guys, are you still with us?
Yep. Good evening, everybody. This is Tim.
Perfect. So, for those of you guys that are new, I do see a couple new names in here. We use GoToWebinar to do these night classes. Everybody is currently on mute, and that's just to eliminate any background noise. Now, if you guys do have a question, and which I hope you guys do, there is a questions panel in the GoToWebinar. So you should be able to type those in there, and we will send those questions over to you right away, or answer those questions for you right away live, and then maybe even go into a little detail for you on how a certain feature works, or if you're looking for something specific or something like that. So, and with that being said,
Kevin, yeah, we got a question already there as far as sharing the data, the files that we're using.
Let's see, can you send me the file tonight we practice? Yep, we can send that over to you, Heinen. Absolutely. So if you guys are looking for parts, definitely let us know, and we can send those over to you so you guys can use them as a practice or a refresher too. And with these night classes, these are solely dedicated for you guys. So send us your ideas. We'll send you some SolidCAM swag, hat, and T-shirt, and we'll get those implemented into the night class setting. So, like I said, if there's something that we've kind of gone through and haven't covered, I was kind of looking through the emails tonight, and I think we got about 15 emails in there from a bunch of you guys sending topic ideas in there. So, and we're going to be getting to those real soon. So definitely send those over to us, and we'll get those implemented in. And then for those of you guys, let me do this. I will put my email address at solidcam.com here into the GoToMeeting, so you guys can email me your suggestions. And then also, every night class is recorded, so you guys can come back and watch it. So if you guys head over to our SolidCAM University channel, if you guys just go to the search and type in KevCAM or type in SolidCAM University, the channel should pop up, and kind of going through, got a couple quick, quick little videos in here that we just added one today on the tool sheet, some live cuts, everything in here on how to do pretty much everything inside SolidCAM. So great source right here. And like I said, every night class is recorded. So here's the one that we did last week right here. With the simultaneous 5-axis roughing there. But I guess with that being said, I'm going to drop this over, or switch this over to Justin here, and Justin can show us some cool tips and tricks doing this impeller. So I'm going to make you presenter here, Justin.
Okay. All right. Well, thanks for having me, Kevin. As you can see, one of the ideal 5-axis parts would be an impeller. This one is an impeller with a splitter. Makes it a little bit more difficult. SolidCAM has some special functionality to tackle impellers. One of our new modules is the multi-blade. I'm not going to use that today. I'm going to use some more old-fashioned tricks that we have. One of those is called area roughing. And if I pull up my help menu here, it'll show you all about area roughing. So you guys don't forget about your help menu. Type in a topic, list the topic, and display it, and it'll go over that. It's kind of cut and dry. It's not a training, but it does give you what you need, the bare bones of what you need. So that's what we're going to be using today to rough this impeller out. Okay, so I've already got my coordinate system on there. I already have my stock defined so that I don't have to do any extra work. So all I really need to do is a portion of this and then transform it. So the first thing I want to do is I want to orientate or find some kind of landmark. So I'm going to use this y-axis, this blade, and this blade. And what I need to do is basically rough out just this intersection here. And really all I need to do is cut this blade and this blade. So that's kind of eliminating this and not looking at it as such a hard project to tackle. So now we're just looking at this floor and then these two blades to get this done. So I'm going to go ahead and do that area roughing trick. Now, I can't go into a lot of training details on this because it is very complicated. So what I'm going to do is I'm going to try to go through it as much as possible, you know, explain what I'm doing here and there, and then at the end we could actually go over some more questions if you need. So I'm going to go ahead and do all of this in simultaneous 5-axis. In order to do the area roughing, we're going to have to do more parallel to curves. And what that does is that opens up for more drive surfaces and more curves. If you notice, it says curves. So that's what's necessary in order to get this. So now using my landmark here to keep myself orientated, I'm going to start at the blade over here and start selecting my drive surfaces. We'll get the vane here, this side of the blade there. We'll get the splitter in here. The vane.
Yeah, and what Justin was talking about, just working on a certain section of the area is, like I said, we'll get this, Justin will get this all roughed out, finished on just that one blade area. And then, you know, once we have that, everything just perfect, fine-tuned, everything looking good, then we can go back and do a transform and do all the blades all as one. So don't worry about, like you were saying, you know, trying to get this all done in one shot, taking just in a small piece of the pie.
Okay, and now I need to select drive curves that are as close to the floor as possible. In this case, it's going to be at this fillet. One thing that really makes an ugly 5-axis job is when you get twisted fillets, because then your tool axis control goes out the window. I'm going to show you how I'm going to tackle that by actually avoiding the fillets and separating them as a separate operation. So now I'm going to go ahead and select my drive curves and make sure that I'm still orientated where I need to be. Yep. Kind of zooming in there. You guys can see that kind of that ugly twist in there. That's not helping us. So accept that.
And one trick you guys can do as you're, you know, like Justin's saying, is keeping it, just working on that specific area. If you guys want to go through and just color coordinate your blade, so maybe just the area that you want to work on, change it to a different color, and makes things a little bit easier to remember where you're working on.
Yeah, that's a good idea as well. Me, I always got to do things the hard way.
Yep.
Zoom in there. There we go. Got to make sure that you get all of your funky geometry that's in here. Now, in a perfect world, this impeller would have no radiuses, no fillets, no vanes here, no twists, and it would make all of our lives easier. But in this case, we get to get challenged with an import, which makes it even funner and more difficult. Okay, so I got my drive surfaces and my drive curves that's necessary to do an area roughing. And if you have any questions about that, feel free to go into your help menu and look it up. It shows you how to do it. Okay, so next on the list here is tool. And it's popular for impellers to use, well, it's not popular, it's necessary for most impellers to use taper mills so that you have, you know, the most robust, but also the smallest tool that you can get in there. So that makes it effective, basically. So we're going to go to my taper ball mills. And I've created a special one just for this job, which will be able to do the roughing and the finishing. And it has a 2 degree or a 1 degree, 2 degree included angle or 1 degree, has the fillet I need, it's strong, it's robust, so it'll get the job done. Okay, now on 5-axis, levels are very important because it's going to tell the tool how to retract from the surface and how to approach the surface. So in this case, we're not going to use a cylinder, we're going to use a sphere because that would be perfect for this job. We'll put a 3-inch radius on there. And also here you can see that you can actually hug it around the, if I left it at 3 inches, it would be 3 inches from here. So if I back it off a little bit, the origin of it, and make it 1/2, that'll just make it a little bit more effective. Here we have our cut tolerances, normal things. Step over, I'm not worried over right now. Tool axis control, there's a lot of options in here. Typically, I'm going to use either one of these two if I'm just doing free full 5-axis without having to, use tilt lines or something. In this case, ISO works a little bit better on this import, so I'm going to select that. And I'm going to kick my tool off at 88 degrees. 90 would be touching exactly on the swarf of that surface. And that makes it hard because you got to have a really perfect swarf. So by kicking it off by 2 degrees, it just gives it that little bit of tilt so I can kind of just go up and down it. It leaves a little bit of a scallop, but at the same time, it makes it easier. Okay, so from there, let's go ahead and generate and see what we got so far. Okay. So I got a little bit of hopping up and down. I'm not worried about that. We're not cutting this right now. We're doing an area roughing, but I definitely have my vectors going in the right direction and everything. So I like that. So the very next thing I need to do is I want to cut just the floor. I want one cut. So I'm going to do determine by number of cuts, generate that. And now I have nice clean tool path going around the blades. So now I can go to my roughing and more, use my area roughing, and keep in mind this is the older way of roughing, and we do have other modules, 3DI machining, multi-blade that makes our life so much easier, but this is the way I actually used roughing for impellers when I was a customer. I don't need to trim it. 50 thousandths is good. Smoothing above the splitter is pretty important. I don't want zigzag climb only. I want to do a regular zigzag. All right, let's generate that. And that looks great. Other than it looks like it's pretty much gouging in here. So now we can go into our gouge control and take care of that. So I know I'm going in between these blades, so I'm going to go ahead and say, you know what, for a drive surface, this is kind of opposite thinking here. This is my drive surface because that's what I'm using for my multi-blade. I'm going to actually do a tilt tool, and automatic is fine. And then for the drive surface, I'm going to use a check surface. Sorry if I'm confusing on that, but the drive surface is what you cut, a check is what you don't. In this case, because I'm using area roughing right now, they're opposite, but don't overthink it, just go flow with it. So now here, I need to leave 10 thousandths on the floor. And then here for drive surface offset, I want to stay away from that blade 15 thousandths. So I'll go ahead and generate that. And impellers are pretty much, you want to do your finishing and dial in your roughing, and then from there do all of the removal of the material. That way you don't have to wait for calculations, things like that. So you can see here now I got a nice clean tool path. So if I do a solid verification on that, it's cutting right to the floor. I want it to do that. We'll do the step downs after we're done here. I'm going to go ahead and dial in the finish passes after this. And that's exactly what I want. I got it to rough out that floor without making any gouge checks. I'll use my stock and machine comparison. And I could see that blue is positive. I got plenty of blue, nice and clean. That's exactly what I'm looking for. So we're ready to move forward. That's the hard, well, it's all the hard part, but that's one of the hard parts. Is getting that area roughed out without having to make surfaces and things like that. So now we're ready to move on to the blades. So I'm going to start finishing the blades, the fillets, and then we're going to go back, finish the floor, and then we're going to add the roughing in, and then like Kevin said, we'll transform it all. So we'll go ahead and add a new 5-axis simultaneous toolpath. This time I'm going to do morph between two curves because it's got that little twist down there and then a nice clean up here. Drive curve. And to get started, I'm going to pick on the splitter using my orientation here on the y-axis to know where I'm at. I'll select my drive surfaces. Whoops. Let me unselect that. There we go. Select. And select. Start edge curve will be the top. Looks good. Move on to the bottom curve. into this nice little twisty area. Accept that. Okay, I want to grab our tool. We're going to do our levels, very important. Toolpath parameters, I want to go 25 thousandths to go down that blade. Give ourselves a nice cut tolerance to 2/10. Tool axis control, like I said, I'm leaning towards ISO. Depending on the part, one works better than the other. You just got to play with it. Again, I want to stay 88 degrees. I just want to tilt, not exactly 90 to where the whole tool's rubbing on the side of this, but just kicked off just a little bit. Let's generate that and let's see what we get. Okay. Not that great of a tool path. Got some vectors going upside down. This is what happens when you deal with imports. You get a lot of inaccuracies like this. So to deal with inaccuracies, we're going to do what's called margins. And this is something that we really play with. How far do you stay off the surface before it becomes accurate? And when you're doing morph between two curves, you get two margins, a top and a bottom. When you do parallel to one curve, you get one margin. So in this case, I got two margins. So being that this is highly inaccurate, I'm going to add in the margins that I want here. And I know these numbers, you guys. I would play with them otherwise, but you don't want to sit here and watch me play with them. So I know these are the numbers that are going to get me what I want. I'm going to generate that. And I got a much nicer clean toolpath here now. Okay, so let's simulate that and let's see what happens. Looks like it's working fairly well. It's getting as close to the fillet as I can at the bottom there. But I'm not trying to complete the fillet. I want you guys to really notice that I don't want to try to complete this fillet at this time. It's not going to work. And I'm not adding the fillet into the drive surface because my tool axis control will go completely out the window.
Is that because that fillet does such a wild twist around there?
The twist and then also tool axis control between the fillet and this side are completely different.
Gotcha.
So if I want 88 degrees here, I don't want it to be 88 degrees over here. It's just going to go through the part. And that looks pretty clean. I do have a little bit of rubbing right here, as you can see, and a little bit of rubbing right here. So being a perfectionist, I would like to deal with that. So in order to deal with that, I'll go ahead and use our gouge control, and I'll do a tilt tool, automatic. Another thing too here is under the advanced tab, under the under our tool axis control, there is a line tool axis to planar edge. This is kind of like your swarf, and you can see here when I have it checked, it wants to align. When it's not, it doesn't. It just gives it that added help. So not only did we not only did we gouge check, but we also align the tool to the planar surface as well as we can. Okay, now we can take a look at that. Okay. Now if I measure it, I got all green. And you notice here, these are my colors. Yellow is -2 thou, green is 0. So now I'm in tolerance. I'm happy with this. So now I can move forward. And basically I can just basically do a save and copy. Sorry, I'm gonna open it back up. You can do a save and copy here, put you right into the new operation, and then you could basically just change the to the new blade. So now I'm gonna go ahead and get my new drive surfaces here, and my new drive curves. Looks good. Get my bottom curve, my ugly bottom curve. All right, and let's just save and calculate and see if we just get a free toolpath out of that. Okay. So far, so good. Let's take a look. Looks clean. Got the fillet. And all in tolerance, so I'm happy there. And I'm as close as I can get to the fillet here as possible without actually cutting the fillets. So now I'm ready to move on to the fillets. And I'm going to start a new one. I'm not going to copy it, because if you copy it, you have so many things triggered on there, you're going to end up missing something or forgetting something. So now we're on to a brand new set of geometry. Okay, same thing. 2 boundary curves. Now my drive offset, or my drive surface, is going to be the fillet itself. And we'll do the start curve, will be my top curve. And now I got 2 ugly curves. Whoops, now I'm lost here. Get back. And that's great. Well, you know what? I know exactly where I'm at. Here's my y-axis. Here's my blade. I was doing the top curve, right, Kevin?
Yep.
Yep, okay.
Hence the nice reason to color code different areas too.
That would be a great idea. I'm just that would be a great trick. Next time I will use that trick. Okay. Now in this case, we want to do 1 cut. So we're going to do determine by number of cuts. Okay. And I know there's inaccuracies in this, so I'm just going to go ahead and I want to stay 2 thousandths away from each side of the surface. Same tool. Levels again. Toolpath parameters. Tool axis control. We'll stick with isometric. 45 would probably kick me up pretty close, so we'll try a 30 degree. And that looks pretty good. That's about where I want it, so I'm going to simulate that. And we got a cut right through the blade, which is fine. We'll deal with that. We got to cut through 2 blades actually here. But what I'm really focusing on right now is how does my fillet work or look. And it is perfect and beautiful on both sides, that fillet is. So now I'll go ahead and deal with the issues with the tilting. We'll use tool axis control for that, or gouge checking. And we will do a check surface. And again, we're going to do a tilt tool automatic. And this time I want to stay away from this blade altogether. So I'm going to click on this. And I want to stay from the top of this. See what we get. Okay. Perfect. That is beautiful. Nice and clean. So again, I'm going to go ahead and cheat and copy. This time I'm going to change to the big flute here, or blade. There's my new drive surface. New drive curves. Looks awesome. Oops. Okay. And let's generate that and let's see what we get. Surprised nothing's gone wrong yet. All right. Wait a second. Okay, so I got a bunch of crashing in there. So here's a gouge checking is a double-edged sword. If you continue to gouge check and that is the solution, sometimes you'll never get a resolve. In this case, right now, if I started gouge checking against everything and the tool is just confused and going crazy, but in this case, what if I just turned it off? Let's try that first. Kind of reset, see what happens. Sometimes you got to unwind before you move forward, not keep winding.
And one thing that we've really found out for all on the tech support guys at SolidCAM here is, when it comes to either 5-axis or HSS, even sometimes HSM, it will throw you. You'll get in there and you'll try to fine tune so many things, and it's just not working out. The best thing, for myself and Jess, and what we'll do a lot of times is we'll just delete that operation and start from scratch, and sometimes that will really clear up a lot of things, because there's so many different little buttons in there that you can be selecting or unselecting, stuff like that. So sometimes it does help just to start from a clean slate and try that toolpath over again.
Yep, and that would touch on unwinding as well. So unwinding what you're doing and going back and then moving forward, stepping back, or completely deleting would also eliminate. Sometimes you'll get a calculation that maybe if you selected things in just a different order, then that calculation just came out a little bit different. And those things happen. There's a lot of things being calculated in the background. So now if we look at this, and I'm not worried about it cutting this, because I'm going to rough it out after this. So I'm doing the finish first, and we're going to do the roughing. But by actually unchecking the gouge check, fixed the problem in this case, which a lot of people would not think of to do that. They would think of, I need to keep gouge checking, and that touches on unwinding, especially when it comes to 5-axis. It's very finicky. So this is perfectly finished, beautiful blade and fillet. So now what I have to do is finish the floor, and then we'll add in the area roughing. Well, we have the area roughing, but we'll add in the step downs for the area roughing, transform it, and we're done. So I'm going to copy my area roughing. So basically, out of 3 tool paths, I built this whole impeller. And what I need to do is I need to go into the area roughing, and I need to go 20 thousandths for step overs. The smoothing above splitter is on. I'm going to go into my gouge check. I'll leave the tilt tool on, but I want 0 here on the floor offset. I want to make sure that I have to drop down the tool and do smooth retracts. This is another trick. And these things are all just experience, you guys, and just reading the menus and fighting with it, reading the help menu, and then it all comes together. So that looks good. And then that determined by number of cuts. Oh, one last thing is on my drive surface, let's just bring it in a little closer. And I think that finishes that. All right, do solid verification. There's that smoothing above the splitter there, how it's kind of morphing around there. Awesome. I am happy with that. We'll measure it, and that is beautifully in tolerance. All the way, the fillets, the floor, and that's all we needed to do to achieve this. Now, the next thing we need to do is we need to add in our roughing passive. So now I'm going to go back to the beginning, and I'm going to go to our roughing and more option here. I'm going to add in depth of cuts. So we'll do 7 at about 100 thousandths each, and we'll make sure that that's getting above the blade, or at least above the shallowest part of the blade. So if I look at this here, it's right there, but I got a lot of air cutting out here. So again, in our roughing and more, we'll go to stock definition. We'll avoid air cuts. We'll shrink a 3D offset, and that'll get rid of all that air cutting.
Yeah, because basically by doing that, it's looking at his stock model versus the target model and eliminating all those extra air movements.
Yep. Okay, and so there's our roughing. And then from here, to complete the project, I'm simply going to right-click, transform, do a 4th axis, include the original operation. This is a 45-degree splitter. It has 8 blades, so I need to add in 7 because we already have this one added. We're going to insert that. And there we go. It's complete. And we can run it.
Do you want to play that one through? Yeah. And basically what Justin did is that this went right from the turning project right over into the milling side. So that's why the stock looks that way, as it came off the lathe and then brought over to the mill.
And you can draw that up or import it as an STL right into your milling project.
Yep.
Well, I guess now is time for questions, you guys, while we're watching this.
Jeff, I know you got to have something. No, that was good, he says.
Yeah, okay. That's fair.
Everybody's eyes are still adjusting from the solar eclipse.
Yeah, well, a quiet audience is just as good as a loud audience.
Yeah.
And we got this on YouTube, you guys, so you can watch it again. Again, this is the hard way to rough this out. Our multi-blade will rough this out so much easier. You just pick the hub and the floor and then the blades, and it says, oh, okay, there's everything, and it just automatically cuts it beautifully. So once that toolpath came out, having to learn all this, I was kind of like, really? That's not right. I had to learn all this, and then they just come out with the automatic way of doing it. So
yeah, and we'll actually be covering for you guys how the multi-blade too, but wanted to give you guys a fresh look at old school way versus kind of the new school. So, you know, there's definitely some tool paths in here that are going to be give you a little bit better tool path versus, you know, some of the automatic stuff that we have. So it's always good to kind of show the several different ways for you guys, and then that way you guys can pick and choose on which you think is the best tool path or going to get you the best finish for that particular part.
And guys, if I were to rough this out in the shop, I would definitely use iMachining. I would rough the heck out of this with iMachining and positioning, and then come into some, you know, maybe maybe just try to tackle it all with that, and then just do the 5-axis stuff. You know, that's what I'm really into now. It's really one of the hot things is just roughing bulk material out with whatever you can, you know, 3D iMachining, HSR, and then coming in and doing the final finish.
Yeah, absolutely. Because when iMachine can take over, it saves you guys a lot of time. And like we were talking about at the beginning, you guys just really have to rough out just that one blade spot. You know, so if you want to do a 3D iMachine, you could have that positioned over, so it's positioned to do a 3D iMachine just to work on that specific area using a bounding box. And then, like Justin was saying, is you know, do that transform and transform it around. So don't try to tackle the entire project all within one tool path.
And that goes for any project. Try to simplify it like the CAM's thinking. Don't try to do two surfaces when it can only really tackle one surface on tool axis control, because then you're going to be dealing with twice the problem. So break it into groups that make sense to the CAM and you that are manageable, and tackle each one of those. And that's what I kind of did here. I just looked at it as 2 blades and 1 floor. And then we ended up with the whole part.
Do you have any other questions, guys, while this is playing through here? Anybody that wants to pick Justin's brain on 5-axis? Now, Jeff, that was that taper tool. That was the kind of the tool that you were looking for, right? Can't remember the name of those tools. Okay.
I used you know what, Jeff, I have not used a lot of taper tools, but I just Googled online, and the first thing that popped up was conical, and so I copied one of those conical tools. And you know, in order to make this a relatively short video, I went with one tool, but typically maybe a lot of people who do impellers are going to probably step down maybe 2 or 3 tools depending on the size of the impeller. This one's actually relatively small, so this tool kind of gets away with it. But yeah, there's definitely some interesting tools out there. And if you guys are going to make a conical tool or a taper tool in SolidCAM, I suggest either getting the tool data or sketching it out in SolidWorks, because SolidCAM does have a lot of fields, and it can be a little cumbersome if you don't have that information ready for you to just type it in.
And there was a lot of you guys asking about the barrel tools. That is a new feature that they're adding into SolidCAM 2017. And for those of you guys, we're starting to we're on Service Pack 1 Hotfix 2 of 17. So for those of you guys who want to make the move over to 2017, let me know, and we can get you your updated license and 17. And for those of you guys that are using Simultaneous 5-axis on a regular basis, what I'd like to do is just get one of your CAM projects, and one of the post guys will go through and make sure the post is all good. Everything that we've checked so far has worked just perfect with the post, so don't see any issues there, but we just want to double check for you guys because we don't want to have anything pop up on the machine side. So definitely let me know, or you know, if you guys call in the support, let whoever you're working with know that you'd like to move to 17, and we can get that ball rolling for you guys. Oh yeah, and Jeff said the barrel tools. So yep, it's coming, Jeff. And Justin, have you ever used the barrel tools?
No, I'm not familiar with them.
See, we must be out of the old machining world for a couple of years too long here.
Yeah, what are they?
They're like a barrel-shaped cutter, and they work really good for, I guess, stuff like this too. But I know they all have their purpose, and I think we talked about it when we were going over the HSM stuff. They're
you say barrel, are they like hollow or something?
No, they're solid, but what it does is it's skinny at the bottom, and then it rounds out, and then gets skinny again, kind of tapers.
Oh yeah, I've seen a few customers with those. They have yeah, it's kind of a taper slash ball and mill where it's got an arc to it.
Okay.
Yeah. Yeah, those I have seen those. Those are that one, and there's another one where they have like a sphere on the bottom, and then it goes into another little tiny radius, and then up, and then so that's another kind of compound tool that are coming out these days. It's kind of like a bull nose with a sphere on the bottom.
Looks like we're getting almost finished roughing out here.
Yep.
Now, other than Jeff in here, is there anybody that cuts turbine blades?
Or 5-axis in general. Anybody else have any questions that's maybe their first time here? Go ahead and feel free to shoot us a note.
Justin, what do you have your steps at?
25 on the blades, 20 on the floor. I have 4/10 tolerance on my faceting, so that's why it's kind of slow. So, nobody take this as that's, our simulation slow, but the tighter I make my tolerance in the facets, the more accurate my measurements will be that you were seeing that I was using that stock comparison chart. But the slower the simulation will be. And we have many levels of simulation. We have our host CAD verification, which is really fast. We have our quick solid verification, which is a rendering, which is super fast. And this is our solid verification, which is actually leaving an STL file from the tool. So it's very accurate. Let's see, did I freeze my computer already?
Finishing that larger impeller blade now.
No, I'm only at 6.2 right here, 40% CPU.
And for a part like this, Justin, what computer are you running?
I am running the M6800, so it's a little old. The power station or workstation. i7 processor. I got 16 gig of RAM. And again, this is the sole purpose of me doing all that in the beginning was to avoid having to go through this and updated stock calculation. If you rough everything out and then go to try to do your finish tools and then you make a mistake and then you have to update your stock calculation, it's just going to be a super waste of time. So this is one of the rare cases where I start my finishing. I worry about my finishing before my roughing.
And then Wade popped a question here, Justin. Will roughing with iMachining be a lot faster than conventional roughing?
Absolutely, 100 times faster. We say 75%, but I say 100.
Yeah, a way to answer your question, the tool management and stuff like that, where Justin didn't cover on this one is like putting feeds and speeds in there. With the iMachine, that's all calculated automatically. The only, I guess, downfall using iMachining versus the roughing is we may have to take maybe 1 or 2 additional side step passes because the 3D iMachine is not going to do, tilt the tool over at a certain degree to get, in there because those turbine blades are, curved a certain curvature, so that you may have to just do a couple additional passes in there, but definitely it's going to save you a lot of time.
Right. iMachining won't do simultaneous. It only does positioning. So you would have to tilt that impeller to look at it to see where the most material can be removed and put a sub position there, and then rough out right from there. So basically your rotaries will tilt to that, and it'll just do 3D eye machining. Then you'll tilt it over and do it again, and then same thing with the HSR, and you'll get as much out as possible, and then from there you'll have to get into simultaneous work. And simultaneous is going to be the least effective in roughing because it's going to use standard speeds and feeds, and it's basically 3D work in a 5-axis world. So we all know that our 3D jobs always take up the most time. Well, 5-axis is even more. So if you can rough it out, with a drill, with eye machining, with a standard tool pass first, then that's going to be your best bet to get the bulk of the material out.
And Jeff wants to know, have you used the other functionality in the stock recognition window?
I'm not sure what he means by that.
I'm guessing in your stock definition. Here, well, once this is done here.
Oh, okay. When I was in the 5-axis stock updated stock.
Yep.
Yeah, the expand volume I haven't found any use for. I always just use the shrink volume at 0, and it pretty much optimizes the tool path. But there are some options in there. I'm not aware of why I would need them, but they're there for a reason, that's for sure. Maybe if you had more stock or you wanted to take some haircuts to be easy on it, I'm not sure. But that 5-axis stock definition where you shrink the volume typically makes the most optimization that I've found so far.
All right, Wade said, thank you for the great answer. How are the lead-in and lead-outs with the roughing that we programmed tonight? Mine are usually pretty rough and have not switched over to SolidCAM yet.
The lead-in and lead-outs for each cut are determined in your links. So you have a lead and out for every slice, and a lead in and lead out for every reposition move in 5-axis, and you have a lead in and lead out for your optimization when you do your linking. So in our 5-axis module, you have all the control you ever needed for lead in and lead outs, when you need to use them and where you need to use them.
Yeah, there's a lot of functionality in there, Wade, so you can, like Justin was saying, you can just control, as it's entering into the material. When it's going between slices, you can have a lead in and lead out. When it's going between passes, you can have a separate lead in and lead out. A lot of different options in there to get the ideal lead in, lead out. But the nice thing with SolidCAM is a lot of this stuff that you guys will notice as Justin was programming this, he didn't have to do a lot of, going through each individual, thing with a fine-tooth comb, going through a lot of the stuff where a lot of the default values and check boxes and stuff that's turned on or turned off are generally a good starting point for the 5-axis. So, as I was going through the 5-axis series with you guys, you'll kind of notice I didn't really get into having to do a lot of the nitty-gritty stuff. Kind of left the basics in there, and it gets you a really good-looking tool path. So, Wade, what are you currently using? And then Jeff, let's see, they should add that for 3D eye machine. I guess I missed. We must have been talking about something else when, the stock stuff. Well, it should be for 3D eye machine because it's looking at, with 3D eye machine, it's looking at the stock versus the SolidWorks model in that sense of things.
Yeah, eye machining's already optimized to the max, so.
Are you running across a spot, Jeff, where it's not? Currently using, I guess, to better illustrate my question is SolidCAM protecting the tool from burying itself? Yeah, Yeah, it's in full protection mode, especially with those gouges on there. Absolutely. And then Jeff, yes, but when you are coming up on a saw cut or something. Oh yeah, that's a great point. So with 3D iMachine, what it's going to do is it's going to go based off of the stock that you have drawn in there. Now, granted, what Jeff is getting at here is, when you get a saw cut, that there's no plus or minus tolerance on that saw cut. You'll get maybe plus or minus 100 thou, and sometimes we need to add some additional in there. So, yeah, it's a great point there, Jeff. We can definitely take a look at that in the future for that. And we can talk to Chris about that and see if he can add that in there, especially since it already pretty much has something for that with 2D iMachining. So, great point. Great question, guys. Keep them coming in. If you guys have, and Wade, for yourself, if you want to see, this is just a small piece of the pie. If you want to see more, definitely let us know, and we can show you everything that it can do. And I guess for everybody, I didn't put the YouTube channel in the link. So let me just copy that. I just put the YouTube channel in the GoToMeeting chat for everybody.
All right, there it is.
There we go, finished off product.
My RAM's a little full, but it's looking good. And you guys, I have this part sitting on my desk. This is one of the first 5-axis jobs I did with SolidCAM. Simultaneous. So.
No, looks good. Any other questions, guys, or concerns, or anything else you'd like to see before we chop this off, or anybody want to pick Justin's brain a little bit more? And then, like I said, Wade, if you want to get more information, definitely let us know, and be happy to provide that for you. Wade, where are you located? Connecticut. Okay. Perfect. Yeah, and for, everybody that is watching this on YouTube right now, definitely, if there's something that we didn't cover in here, shoot those over to me in email. In the description of the YouTube video, you'll see my email address in there, and you'll see the where you can shoot me an email, or you can send questions over to our SolidCAM support, which is also in that in the details of the video. So. And then, like I said, anybody that would like to see this or have this part, let me know, and we can put it up on OneDrive and then send you the link, and then you guys can download it and play with it and pick it apart and see what Justin did, if going at your own pace there. So.
Yeah. And you can call me direct on the SolidCAM help desk too. I'm there all day, every day. So.
Absolutely. All right, guys. Well, I guess that's all I have. If we don't have any more questions, I think I gotta look at my calendar. I know I do this to you guys every week, but I don't think we have no, we do have one next week, and then the week after that, was it Labor Day? It's coming up. We won't have a class that week right there. But other than that, we'll keep these going throughout the time and keep working. I think we got a couple more 5-axis ones that we're going to be going through, the impeller, port machining, and all that good stuff, and then we'll get into the turning side of things. So
he means the multi-blade. We did the standard impeller here.
Oh yeah, sorry, multi-blade. Yep, that's exactly what I meant. But Tim, do you add anything else before we wrap up? Nope, there's
And we put him to sleep.
He was having audio issues earlier today. But no, and like I said, guys, I can't thank you guys enough for staying in and watching these classes. And like I said, if there's something that you guys would like to see more, let us know. Justin, thank you for kind of walking through step by step and doing some tips and tricks in here for everybody. And hopefully everybody got a little bit out of or little tip or trick out of here while watching your program. But yeah, guys, let us know what we can do to help you out. We're here to help you out in any way possible. You're working directly with us. You're not working through a reseller. So for those of you guys that are watching this on YouTube, I know that's been quite an issue, especially for company that you're kind of working with there, Wade. But let us know what we can do to help out and to better off your support experience. But all right, guys, have a great one, and we'll talk to you guys soon. Have a great night. Bye, guys.
Thanks. Bye.